Good afternoon, ladies and gentlemen, and welcome to the SAIEE Central Gauteng Centre webinar on safeguarding critical infrastructure against cyber threats. Before we start, a few webinar considerations. Attendees are reminded to ensure the volume is turned up on your device. Ensure you have a stable internet connection. This will ensure the streaming and audio will run smoothly. Attendees can ask questions via the questions panel located within the GoToWebinar control panel. By default, the control panel is located on the right-hand side of your screen. The chat function is reserved for webinar organizers and panelists to communicate with attendees. Attendees will not be able to chat with each other, however, are encouraged to ask questions. A recording of this webinar will be made available on the SAIEE YouTube channel, SAIEE TV, under the Central Gauteng playlist. You will find the registration link in the chat box. Please register to subscribe to it. It is free. A certificate of attendance will be issued a few days after this webinar once we have received the CPD validation number from EXA. I'd like to now introduce you to one of our hosts tonight, Mr. Tsoledi Moloi, who runs the Technology, Knowledge and Leadership portfolio for the Central Gauteng Centre, and he is an instruments and control systems technician at Ardagh Glass Packaging Africa Wadeville factory. He specializes in maintaining and developing new control system strategies that focus on forming quality glass packaging containers. Tsoledi graduated from the University of Johannesburg with a Bachelor of Engineering Technology in Electrical Engineering and is an enthusiast for process automation and control, mainly industrial process automation. Having joined the SAIEE Central Gauteng Centre has exposed Tsoledi to diverse engineering aspects. Over to you, Tsoledi.
Good day to everyone. I hope everyone is doing well. Welcome to our webinar this evening. And well, with me, I'm not only the host, but I'm also with Mr. Khomotso Setlapelo, the immediate past chair of the Central Gauteng Centre. So Khomotso Setlapelo is a registered professional engineer with the Engineering Council of South Africa. He holds BEng Electronic Engineering and BEng Honours Electronic Engineering degrees from the University of Pretoria. He's pursuing an MBA with an emphasis on digital transformation. With the University of Johannesburg Business School, he holds a professional director or SA certification from the Directors Association. Setlapelo is a chief telecommunications engineer at the newly established National Transmission Company of South Africa under Eskom Holdings. With over 16 years of experience, he serves on the management committee, MENCO, of the NTCSA Telecommunications Department and is responsible for overall technical performance, strategy development, and leadership for the operations and maintenance of Eskom's telecommunications network. In that order, I'll hand over to Mr. Setlapelo.
Thank you very much, Tsoledi. Good afternoon, all. It is indeed an honor to co-host this webinar with yourselves as the Gauteng Centre and on behalf of the SAIEE. I am very excited for this presentation with the next speaker also being Khomotso, who is a chief engineering specialist at NTCSA, Khomotso Manyapetsa, who is a professional engineer and holds a master's in engineering, is a highly experienced chief engineer, specializing in control, automation, and OT cybersecurity, with a master's in engineering management and a bachelor's in electrical and electronic engineering. He has over a decade in experience in the power utility sector. His work focuses on integrating SCADA, substation automation systems, and energy management systems, emphasizing cyber physical security for critical infrastructure. So to our attendees, you are in luck. You get 2 Khomotsos for the price of 1. With that, we hope that this Herculean task of slaying the Hydra, that is cyber threats and attacks. Khomotso will do us justice and provide us with means to safeguard our critical infrastructure against these attacks. So without further ado, welcome, Khomotso.
Okay, thank you, Mr. Sitlapelo. Yes, as indicated, my name is Khomotso Manyapeta, and I'll be taking you through this presentation on safeguarding critical infrastructure against cyber threats. Okay. All right, the agenda is as follows. We'll just define what critical infrastructure is and what are industrial cyber physical systems and their role in critical infrastructure. We'll discuss the reference architectures for industrial cyber physical systems, the evolution of these reference architectures, and then we delve in and check the threat landscape, as well as look at the attack surfaces, as well as the attack vectors for critical infrastructures. And why does industrial cyber physical systems need cyber security? From there on, we'll look at the key measures to secure the industrial cyber physical systems. I will use the word industrial control system, cyber physical systems, industrial cyber physical systems, just to mean really the same thing. I'll just use them interchangeably. Please bear with me. Okay, definition of the critical infrastructure. The Critical Infrastructure Protection Act, I think it's a CIPA of 2019, defines critical infrastructure as any infrastructure that the minister declares to be critical after receiving an application from the National Commission of Police or the person in control of the infrastructure. So this replaced or supersedes the National Key Point Act. The minister considers factors such as whether the infrastructure's loss, damage, or disruption could harm the public interest, national security, or the economy, whether the infrastructure provides goods or services that are essential for the public daily lives. The main purpose of the Act is to protect critical infrastructures from threats, whether natural or man-made. Critical infrastructure is essential for national security, public safety, the continuous provision of basic public services. Critical systems include systems such as energy grids, telecommunications, water systems, transportation, healthcare services, nuclear resources, and food and agriculture systems. So disrupting these systems could have significant consequences for society and the economy. Okay, coming to industrial cyber physical systems and their role in critical infrastructure. In today's interconnected world, the integration of physical systems with digital technologies has transformed the way industries operate, although this has been there for some time. Cyber physical systems, or CPS for short, are defined as systems that link the digital and the physical realms, such as industrial control systems, that can be the SCADA, DCS, PLC, that monitor and control processes such as energy generation, manufacturing, or transport. A critical subset of cyber physical systems is the industrial cyber physical systems, or ICPS, which specifically refers to cyber physical systems applications in industrial settings, which are what we are generally concerned with. These systems are vital for modern infrastructure. You can think of power grids or manufacturing plants. They enable real-time control and automation, which significantly enhances operational efficiency. However, this integration with mechanical and physical systems creates a dual challenge. While cyber physical systems improve performance, it also introduces new vulnerabilities. This is especially true in sectors such as in energy or even water and wastewater, where a successful cyber attack could disrupt power supplies, affecting everything from hospitals to transportation. Therefore, understanding that securing cyber physical systems and industrial cyber physical systems is not just about protecting digital assets, but ensuring that the continued safe and efficient operation of our physical infrastructure. I will then delve into the importance of securing the systems to prevent potentially devastating consequences, but that will be later on during the presentation. Okay, reference architectures for industrial cyber physical systems. What is a reference architecture system? Reference architectures provide a structured approach to designing industrial systems. The most commonly applied architecture for industrial cyber physical systems is the one that I've just depicted there, the Purdue Enterprise Reference Architecture model. And the other one is called the Reference Architecture Model for Industry 4, or the RAMI 4, the Industrial Internet Reference Architecture, or the IIRA, and the Smart Grid Architecture Model, the SGAM. These models segment IT and OT systems to improve and ensure that different layers of the system communicate securely. Well, I can say maybe think of them as blueprints that help developers or anyone integrate and secure the components of critical infrastructure system, such as a power grid or water and wastewater network. Their role in guiding the design of resilient systems can generally not be overstated. So I've just shown just the basic Purdue model diagram here, and generally it is not cast in stone, so that what makes it survive for so long, over 30 years, because you can just customize it. Next, looking at the evolution and application of reference architectures. As technology evolves, so does our reference architectures. Older models like the Purdue, as I've shown previously, it is over 30 years, emphasize network segmentation, while newer ones incorporate enhanced cybersecurity measures to address the increasing complexity of interconnected devices. The modern reference architectures include security zones, advanced real-time monitoring, and secure communication protocols. These are essential to protect against modern cyber threats and ensure the continuous secure operation of industrial systems. By using these reference architectures, industries can improve operational efficiency, ensure compliance, and reduce the risk of cyber attacks. So we will talk about this diagram. I've retained it in the later slides, and you can really see that it's still the Purdue model. Really, you just introduced a few buses and the security zone there. Okay. Now moving to the industrial cyber physical system threat landscape. A threat landscape generally refers to the overall environment of potential cybersecurity threats and vulnerabilities that plants or systems or even organizations face. It includes the range of risks, including both external and external threats, such as cyber attacks, data breaches, malware, social engineering tactics, as well as the methods and actors behind them. The threat landscape, I've tried to depict it with this diagram here, of cyber physical system, especially in critical infrastructure, such as where I'm mostly based on the energy grid side, but easily applies to water and wastewater, transportation. These systems are under increasing threat from cyber attacks, from malware, such as, if you could recall, the Stuxnet, which disrupted the Iranian nuclear program, to attacks targeting SCADA systems that control power grids, such as the one we also heard of the Ukraine power grid attack. The risk is generally real, and it is growing as these systems are increasingly connected to the internet and integrated with IT networks, their vulnerabilities become more exposed. In recent years, we have seen attacks such as false data injection and denial of service that can disrupt operations, and this highlights the critical need for cybersecurity measures. False data injection is normally what people like to do in physical systems, but it can be implemented across. You can fool the instrument physically there, or somewhere sitting on the control system. You can also do such things. Next, now I just want to look at the attack services and the attack vectors for industrial cyber physical system. Attack services and attack vectors, looking at this schematic, the total attack surface comprises all the points at which vulnerabilities exist, and an attack vector is the path or means with which the attack is carried out. Some examples of attacks include phishing, malware, exploiting unpatched vulnerabilities, social engineering, amongst others. But just to use this example, which is for a substation, but if you zoom in correctly there at the right-hand bottom block, you can see that architecture is typical of any industrial setting. Your MU, imaging unit, and circuit breaker ID, that can easily be replaced with a generic sensor and an actuator. Then the IEDs, you can just replace those with the controllers, and at the top there, it should be the same as most critical infrastructures. And then utility one is there because of plants that are geographically dispersed. But if they are not there, it's just a link that will link you to a control center. For example, in a power station, you will just have cables to a common control center, which is shared by different generating units. This should be the same even for oil and gas. So now let's just check at the first attack where number one there for the bottom right block, external network and access initial exploitation, and the path that is typically taken there is from 1, 2, and 3. Basically, let me just explain it. The first step of any attack often begins at the external access points, such as the internet-facing systems, such as our VPN, which can be exploited to gain unauthorized access into the substation's OT network. Attackers will generally use techniques such as phishing or malware delivery through an email or web traffic to penetrate the system. Once access is gained, attackers tend to proceed to bypass firewalls, which are designed to control traffic and protect the internal networks. By exploiting perhaps known vulnerabilities or misconfiguring firewalls, such as leaving open ports, attackers can then bypass these security layers and gain deeper access to the network. Once the firewall is bypassed, attackers can then access the internal network of the substation, which is number 3 there. Okay, so once they are there inside the substation, then they can target the critical control systems such as your RTUs, anything just in there. They can attack that. But I will explain that more when I come to that part. The second one now is gaining access to the substation via corporate network, where the attacker is somehow within there. In this attack path, the intruder first gains access to the corporate network, which is number 30. Which is connected to various substation systems. This can happen through remote access points such as VPNs or wireless access points that are improperly secured. Once the attacker has access to the corporate network, the next step is to compromise the firewall, number 12 there, which serves as a barrier between the corporate network and the more sensitive substation networks. By exploiting weaknesses or any misconfiguration that could be there, the attacker can bypass this critical defense. Next, the attacker will then target access to the wide area network, which is often used for communication protocols such as your in power industry, your IC 103, 104, DNP3 in distribution number 10. These protocols are widely used for remote control and monitoring of electrical substations. And if attackers gain access to the WAN, they can intercept or manipulate this communication to cause disruptions or manipulate the data. With the substation firewall already compromised at number 9, the attacker can now navigate through the WAN to the substation communication network, which is number 3, which is then directly connected to the operational systems such as SCADA or other industrial control systems. Once the attacker is within the substation network or any plant network, they can then target critical control systems, potentially changing settings, disrupting communication, or even manipulating equipment, thus posing a significant operational and safety risks to the entire system that is being under control. It could be the power system. So another path now is at number 15 at the control center now, is when you gain access via the control center network. Number 15, that's number 15, then goes to number, 15 and 14. 14 is this firewall. Then goes to number 10, utility WAN. Number 9 is the substation firewall or the plant network in question, and then 3 is inside the substation. This path focuses on insider threats, where the control center network number 15 is targeted by an attacker with an authorized access or privileged credentials. Insiders exploit this access to compromise control center network systems, potentially by bypassing traditional network defenses. Once inside, the attacker gains access to, as always, sensitive systems where they can target key substation systems such as your gateways, RTUs, and either by manipulating data or altering control signals. The attacker then moves to gain the WAN, utility WAN via number 10, leveraging access to wide area network to further infiltrate substation networks or any other network. They then exploit the firewall vulnerabilities, which is number 9, opening the network and gaining access to the substation network number 3, where they can carry out further disruption or data manipulation. It just depends on the objective of the attacker. Another path is coming from other substations. This is the same as others. Maybe just to save time, I'll then skip this and look at the path where the attacker is within the substation or the particular plant, any plant really. As you can see, the reference architecture is still similar to the initial one. So once the attacker is inside the substation internal network, inside that network, they can then exploit multiple pathways to reach key systems within the substation. Attackers can target devices at the bay level or the control or the panel level, such as protective devices and others. The rest of the other industries is most likely controllers, and potentially they will then alter their settings to cause operational disruption through attacking any of these. You can see number 5 there and number 8. The number 8 is just at the field. They may also move on to process level devices. The rest of the industries is your instruments, your many instruments and actuators. Yes, so okay, I think maybe I will move to the next step. So this really shows you holistically different attack services and the scope of work that is required to secure these. Why industrial cyber physical system needs cybersecurity. Given the critical nature of these systems, a cyber attack on an industrial cyber physical system can cause more than just operational disruption. It can lead to major financial losses and poses a significant threat to public safety and even the environment. Examples, as we like mentioning, that the Stuxnet, the Ukraine power grid attacks emphasize the devastating consequences. And if you recall, in South Africa in around July 2021, Transnet, which is a key operator of South Africa's ports and railway networks, fell victim to a cyber attack that severely disrupted operations at the Cape Town and Durban ports. This attack, coupled with the countrywide civil unrest at the time, forced Transnet to declare force majeure, and this resulted in significant delays. The workers had to revert to manual cargo processing, causing huge backlogs, especially for refrigerated containers. Things were rotting there. If I recall, I heard people mostly on the radio, on the news, that there was a serious stench coming from the Cape port side. So this type of attack also disrupted international trade flows, particularly for Southern African exports such as copper and coal. This cyber attack it's said to have impacted Transnet operational technology systems, including the Active Directory server. Not much further details was provided on what exactly was attacked. What we know mostly is the impact. The company said that it responded by their response rather to the attack involved rebuilding the compromised Active Directory server and fast-tracking the deployment of a Microsoft security product. And they say that older operating systems were upgraded and fully patched before being brought back online. Additional security measures such as web access, firewalls, and anti-DOS protections were also put in place to mitigate future threats. As IT and OT networks converge, most plants that have not experienced this type of convergence, ensuring that the security of cyber physical system then becomes paramount. It's important then to look at industry standards and implement layered security strategies based on, I think the most important for operational technology is the IEC 62443, as well as the ISO 27001. These are essential sometimes to minimize the vulnerabilities and protect the critical infrastructure. Now, key measures when you look at the key measures to secure industrial cyber physical security, these are important to secure the infrastructure. But first, we need to understand the attack continuum. This attack continuum model provides a framework for security strategies, and it is divided into 3 phases: the before attack, during the attack, and after the attack. If one understands these phases, it's important to understand the phases because this continuous model aligns with how companies secure, defend, and audit networks on a daily basis. The attack continuum can help analysts or administrators or anyone suggest better solutions for continuous protection. It emphasizes the importance of a holistic approach to security. Looking at these phases briefly, before the attack phase, one needs to know what they are defending exactly. A complete device inventory is necessary to implement access controls, enforce policy, and block applications. Solutions such as firewalls, next generation firewalls, network access controllers, and even identity services or directory services are key to detecting and preventing threats. Now, during the attack phase, once an attack is detected, it must be blocked and defended. Detection tools or devices such as next generation intrusion prevention systems and other security solutions that I just mentioned now can help protect during the attack. And lastly, after the attack phase, in the event of an attack, one needs to scope the damage, contain the event, remediate, and return to normal operations. Often there is a long-term outage. It just doesn't happen quickly. Sometimes it means you need to rebuild. Solutions such as the SIM and network behavior analysis devices are important for remediation and minimizing the damage. We'll just have a look at this next. Okay, key security measures must follow a defense in depth principles. Each layer of security plays an important role, from the plant network to the network perimeter. The layers must work together to ensure the protection of the critical infrastructure overall. When it comes to directory services, such as Active Directory or LDAP, there's many variants of LDAP, which are normally even open source. These are essential for managing access, control, and authentication in critical infrastructure. And these have barely seen widespread usage or adoption within the OT environment. Directory services enable device management to ensure trusted devices connect to the network and enforce security policies, and as well as compliance. Things like endpoint protection practices can be implemented through such directory services. Plans or systems can authenticate users and devices based on network access policies that you come up with from before the system has been commissioned. You can track device configurations and monitor compliance. The goal ultimately is to achieve total visibility of all the systems and its components, as well as the networks, to detect and mitigate threats. Also, it is to ease the administrative burden, given the proliferation of devices that needs to connect onto the networks as a result of Industry 4. Next, I will then talk about the segmentation, interzonal communication, and monitoring, as well as incident response. Okay, secure industrial control system network security can be achieved by properly segmenting the industrial control system environment, focusing on essential systems and equipment or devices on the industrial network, and avoiding foreign or exotic devices such as mobile phones, removable storage media, and even laptops. These are enterprise laptops. They don't belong to that network, and that's how most of these air-gap systems end up getting ransomware. It's via removable media. Even laptops can do that. So proper segmentation is the first basis of a secure industrial control system architecture design, ensuring that only essential equipment is needed for the production process and minimizes risks to the overall cybersecurity posture of that particular system. The industrial network should be segmented into enclaves, sometimes called that, but it normally means a network subnet or a VLAN, allowing closely related industrial control equipment to communicate unrestrictedly at layer 2 speeds on the same switch or virtual area network. This process sometimes is referred to micro-segmentation. Proper segmentation reduces the attack surface and increases overall network performance by minimizing network broadcast domains. It also creates network traffic choke points, designated spots for efficiently capturing interesting network traffic. And this idea, normally, if you check physical security, sometimes the idea, the concept of segmentation needs to be applied there as well. Otherwise, when a lot of broadcasts happen as a result of just one device, the whole network goes down, your physical security network. All related industrial control system equipment should be kept in its own functional area and network subnet to improve security and performance. On level 3, the site operations should be used as an intermediary to get to and from the industrial control equipment at levels 2 and below, following this podium model, and preventing bypassing security boundaries. And normally firewalls are the ones that does that. All right. Now here's the focus is, the focus is on defining and controlling secure interactions between security zones in an industrial control system, while isolating the industrial control system from the rest of the organization would improve security. The demand for interconnected systems driven by the Industry 4 and analytics, and the fact that the bulk of the users are sitting on the IT side. This really necessitates a secure cross connectivity. Then to achieve this, we can apply the concept of a demilitarized zone, sometimes called a perimeter network or a screened subnet, to secure internal systems from external access. The industrial demilitarized zone, its purpose really is to broker communication between the enterprise zone, which is insecure from our perspective, and the industrial zone, which is secure because it's what we are controlling. The industrial demilitarized zone ensures that if a compromise occurs, for instance, it's contained within the demilitarized zone, safeguarding the internal systems. So with this approach, it can help segment critical assets and allowing secure interactions without exposing the industrial control to unnecessary risk. The key design goals are to segment the industrial control system network into security zones and micro-segment the industrial zone, as well as to control all access through a properly designed IDDMS. So it's very important that we don't allow this. And sometimes the historian server is normally put here and users can just directly access plant information. Now looking at security monitoring. Security monitoring involves various tools and techniques such as log monitoring, intrusion detection system, security devices. We can have vulnerability management, and as well as a SIEM or security information and event management from a coordinated and correlated point. This is to ensure that the industrial control system environment remains secure and operational. Key concepts include network choke points. These are strategic locations in the network where traffic between security zones can be captured and monitored for security analysis. Packet capturing at different levels, whether it's an enclave level or a subnet or same VLAN. Here we can capture traffic using span ports on switches within a subnet level or VLAN. Cross enclave, that's like inter VLAN, capture traffic between different security zones using firewalls or data collectors or even routers. At site operation level, it's level 3, we can also use span ports on core switches to capture traffic to and from site operations, which connects the industrial control system network with higher level systems. And then the industrial demilitarized zone, there we need to monitor traffic between the enterprise zone and the industrial control system or industrial zone, focusing on communication and detecting potential security threats. Logging and alerting all industrial control systems should be configured to generate events, logs, and alerts. These logs are then collected by a SIEM solution to provide a centralized monitoring and real-time detection of security incidents. Overall, security monitoring involves a layered approach, utilizing packet capturing, SIEM solutions, and proper network design to ensure that the industrial zone security and prevent unauthorized access or malicious activities. Okay, when it comes to incident response plans and automation, automating incident response, leveraging security or a SIEM tools and automation platforms to detect, respond, and mitigate security incidents quickly. Automating responses ensures faster reaction times during the cyber incidents, reducing damage. Comprehensive incident plans. You need to do regular testing of incident response plans, helps maintain preparedness for any potential cyber attack. These plans should include forensic investigations, communication protocols, and steps to restore functionality. Another good device there is the network access controller. We can have things like role-based access control and policy-driven security, which are essential for managing access to networks, particularly in highly sensitive environments like industrial control settings. The network access control ensures that devices are compliant with security policies before they can access the network. This can mitigate risks from unauthorized or unpatched devices, maintaining a secure network perimeter. Also, you can use, it allows the use of MAC address filtering protocols such as IEEE 802.1x and also certificate-based authentication. Also, note that a network access controller can also manage and enforce security policies for network devices such as switches within the infrastructure. So you can easily, if one controller was misbehaving, if you wanted to isolate it, if you have this device, you can close the port and isolate that particular controller or device. Key takeaways. Number one, we need to use layered security approach. A defense in depth strategy is a requirement for protecting industrial cyber physical systems by implementing multiple layers of security, ranging from network segmentation to firewalls, IDS, and intrusion prevention systems, as well as SIEMs. We ensure that each layer reinforces the others to provide comprehensive protection. Total visibility is key. Achieving total visibility of all systems and network traffic within industrial cyber physical systems allows for early detection of threats and quicker responses. SIEM solutions, intrusion detection, and network monitoring are vital tools for maintaining this visibility and ensuring that any suspicious activity is swiftly identified and mitigated. I have always found it quite strange that the operator of any plant can see everything on the physical plant, but the administrators cannot equally see the computer network, and yet it is the very same networking infrastructure that makes it possible for the operator to fully view the primary plant. So this is something that is already there, should have been there for many years. Number three, integration of cyber and the physical security. Effective security requires just strong cyber defenses, but also robust physical security measures. And some people are already adopting this, using cybersecurity for their physical security. So integrating, okay, I can also add that integrating or the use of directory services, network access controller, and the physical barriers helps secure both the IT and OT environment, and it can ensure that access to critical systems is tightly controlled. continuous monitoring and response. Security doesn't end with initial configuration. Continuous monitoring, logging, and incident response planning are essential for maintaining the resilience. Automated tools and playbooks for incident response ensures fast action and minimize damage when it occurs. So we also need to strive to build a resilient industrial control system architecture, because a well-designed network architecture with built-in security is essential for long-term protection of critical infrastructure. So we need to prioritize this secure network design, and then we can put in things such as segmentation, layer defenses. And then I might have not mentioned this, but across this diagram, you can see there's devices at every layers. I did not mention hardening across the levels, but it's also important. We need to look at endpoint security and hardening. We need to, endpoint security focuses on securing devices that are mostly at the edge that connect to the network. And this could be workstations as well. The hardening of them involves applying security configurations such as disabling unnecessary services, and also we need to also ensure that there is some strong authentication methods for those devices. And we know there's a big problem in industrial settings where authentication does not exist. Anyone can access the device if they want. Operating system security or hardening. This one, we need to focus on reducing the vulnerabilities in the operating system layer of the industrial control system by removing unnecessary services as well, applying security patches that are required, and enforcing least privileged access for users. We also need to disable guest accounts there, enable audit logging, and also you need to have a secure boot of that system. When we look at the application security, the application is what normally your vendor does, your SCADA or DCS application. That one normally you just have to work tightly with the OEM of that product and ensure it's regularly patched and configured securely to minimize the attack surface. And as always, least privilege should be applied there as well. When coming to anti-malware, these tools are important for detecting, preventing, and removing malicious software, including viruses and ransomware. And there's no reason why you cannot have this in a workstation, an engineering workstation. I don't see any reason there. And anti-malware generally is also essential to it's important because it also has features such as behavior analysis, which can be used for detecting previously unknown malware just by behavior. Additionally, hardening of systems involves ensuring that malware prevention tools are not disabled. When we look at the network now, the network hardening, we require it so that we can ensure that this industrial network is protected from unauthorized access and attacks. Strategies there include also implementing network segmentation to isolate critical systems using your firewalls and other security devices. VLANs should be used to segregate traffic by type and secure protocols. And then when we look at OT-IT at this layer, this is an industrial DMZ, but as you can see, the IT comes with us with their own firewall. We come there with our own firewall. So this part is important to keep it secure, that interface, as these are often that can be the weakest link. Access control measures such as the use of a network access control should be used to ensure only trusted devices can access the OT network. Firewalls should be deployed between IT and OT networks to enforce separation and data encryption sometimes. But I can tell you there are a use case where the device in the industrial setting connected directly to there's a server connected directly to some switch this side. So these things are happening out there where people are not following these things. And then lastly, regular monitoring and traffic analysis are important to detect unusual activity that may indicate an attempted breach. So yeah, with that, I would like to take this opportunity and say thank you for listening. Thank you.
Thank you very much, Khomotso, for a very informative, eye-opening presentation. To the attendees, you are more than welcome to post your questions in the chat box that is provided. We will now go into the Q&A session. Perhaps I should start off, and then we will take a question from the chat. I think Roni, welcome. In fact, his question triggered mine. Khomotso, you, in I think slide 7, mentioned that even legacy OT networks that are not connected to the internet are vulnerable. Maybe if for me unpack this, I guess I'm still a bit old school in managing a legacy network. And then I think you also then referred to Stuxnet. Is that sentence, maybe unpack it for me, the sentence around OT security not being, or being still vulnerable, even not connected to the internet. The context, or maybe my definition of legacy may be different from yours. So the context of legacy that I come from would be time division multiplex networks with non-routable or serial networks with non-routable protocols. So how would then, a vulnerability or an attack propagate through such a network? And many utilities currently still have these in operation.
Okay. The Iranian nuclear facility was air-gapped. And for me, as long as a network, or it's a network and it has people working on it, it can always be brought down, because it's through the people that this can, the attacks can be manifested. Stuxnet, it came with as a result of removable media for people to then be able to exploit this. There was no ways it could come in via networks, because they were not even connected to, it was an air-gapped or islanded network. So people had to bring in USB or anything to infiltrate that plant. For legacy systems or legacy, even a device, there are instances in our OT networks. I don't know, there's this tendency to like old things, even though you can quiz any OEM of any product, they will never say use that. They always advocate also keep up in a way, but maybe the pace is not fast enough. But you will find people using things like Windows Server 2003 till this day. You don't understand. If this plant is making revenue for your company, why would you then use such old unprotected? Because there's so many patches that are released. Somebody always finds a loophole, and the owners of this software, they come up with hotfixes or patches to fix whatever security vulnerability that could be there. And you find that if you are now using a legacy system, it means you are susceptible to that. Anyone needs to get access to your system, they will know how to bring it down. And access in most of the industrial plants, for example, a plant at some point needs to go on outage, and somebody can access that. I'm not sure if I'm going out now, but you will find that control measures that are put in place are the ones that were done maybe say since 2008. So people who left the company in 2010 still know how to access a particular OT system in 2024, because things such as your product remains the same. You don't affect good practices such as lifecycle management. Even the person you bought this from has always said you need to move on. You miss patches to a point where you can't patch, but you must get a newer one. So legacy systems, for me, I don't know why they are being used. There's more reasons to move on than to retain that, but they are easy to compromise, because in alignment with continuous improvement, they are behind, and it's easier for somebody to bring them down, because they will just look at some of the patches, some of the vulnerabilities against that system, and just use it and practice it. So I'm not sure if I'm sorry.
No, you are. Maybe as a follow-on, and then I'll take. Thank you very much to everyone that has posted questions. We will take questions. We are scheduled until 12:30, so we will definitely have a conversation. So maybe from a threat analysis perspective, just following on from my own question, does that not then narrow down the field of potential attackers? If then you know, and again, there are a number of reasons why we don't refurbish networks on time, finances being a huge part of it. But from a legacy network perspective, does then that not narrow down the list of potential attackers, given that those would be, you know, people that have worked on that network before, they will have an intricate knowledge in that equipment. It's not very easy to get that legacy equipment out in the market for, let's say, a very curious 16-year-old to want to then find out how this thing works.
Yes, for new chancers, yes, it becomes difficult for them to do that, but the people who have been there, it becomes easier. For them, it's easier. They normally, because OT for a long time, people need to access the network physically. So it always relied on someone to bring, whether it be a malware via some form of removable media. It can be narrowed, but information is now available. And through virtualization, for example, you can extend the use of legacy devices, but at the same time, that 16-year-old can also learn. If he can get a replica of it, he can just learn it in his virtual environment. And normally for me, what I would like to argue with the system owners is that if a pump fails in a plant, that pump will be replaced. And I can simply ask a simple question: how much is that pump that is going to be replaced? And I can tell you, with that money, you can replace so many OT networks. The OT network to me is cheap. It has always been cheap. It cannot compare with a transformer, for instance. But when a transformer fails, it will be replaced. So I don't know, and I cannot say it's the people who work with this, who take care of the systems that do this. I know generally they try. There's always some sort of rejection when it's time to release the funds. So yeah, it's for continuous improvement. So meaning the legacy has missed a lot of things, and there's much more room for it to be attacked. That's how sometimes I see it. And for example, some of the protocols that are quite old, there's not much security put in place there. Although you can use new technology to still, for example, if you use a tunneling, you can just tunnel an old thing, then you know there's no man in the middle attack between 2 points.
All right, no, thank you. All right, then that's probably a nice segue to a question from Ronnie, who says, so in terms of slide 8, surface number 3, physical security and RBAC is critical to secure the ICS. Your comment on that?
Okay, he says, Ronnie says that physical security is,
and RBAC is critical to the securing of the ICS.
Yes, we normally don't say this defense in depth. Nobody mentions that once physical security is breached, it becomes now free game now for all this equipment. If somebody cannot crack a password, they can just use their hammer to, at least they know they would have. So it's very important, physical security, to ensure that it has this role-based access control, and those devices, now that the people are now using a lot of CCTV and a lot of sensors, all those devices now need to be managed as well. And now if you don't use role-based access control, I just wonder whether if one security device is being compromised and the network is not done as it should be, segmented and all that, if somebody can just put one sensor or one CCTV, bring down the security network, thereby taking out visibility of whatever plant, it then means the guys can come in and do as they see, please. So role-based access control is very important, and I'm just tempted to talk about directory services to emphasize why I was talking about it. A lot of switches, routers, they all have this problem of having admin passwords, and there's 5 of us working on those devices, and we are not including the previous people who used to work in. So it's tough to change the passwords. Even if we change them to another password, the 5 guys must know it, and there's a problem. And one way is to use directory services to then take away the that local logging of that device and put it in some form of a directory, where at least, even though that directory has its own weaknesses, it can at least be reduced to a few people who access it. So role-based access controller, yeah, it is important.
Okay, thank you very much. So the next question is from Banele Soni, who says it can be difficult to convince the business to invest in OT cybersecurity when an organization has never experienced a cyber attack. What is the best approach to convince the business to invest in cybersecurity solutions, especially in the OT environment? And how do you quantify potential financial losses due to cyber attacks?
Yeah, this one is generally difficult. I don't think, unlike IT, in the IT space, it is possible to separate security. But when you come to the industrial control system side, it's really hard to make cybersecurity a standalone. I try to just ensure that it goes with the system. For example, if you need to upgrade your SCADA, you need to make sure that the requirements include even the cyber part of it. For example, you can't buy a SCADA system with an application that is flawed. Already means on your requirements you need to request that. So it's hard, as a standalone is hard. Yes, if an organization has not experienced an attack, yeah, they don't believe it. If I recall, we struggle a lot in the operational technology space with obsolescence. For me, for the longest time, I've always been scared of obsolescence than cybersecurity incident, because even if they say cyber froze, I just know it must be the server somewhere there, and you try to solve just that part, and it becomes difficult. So I'm not really sure how to factor on its own. I cannot factor it, but I couple it with the system. If the system is due for maintenance or anything, I ensure that the cybersecurity requirements are inherently in there as well. yeah, if I need to, for example, you need to move from just a bad example, Windows 10 to Windows 11, and I know there were some weaknesses on Windows 10. I just ensure the next operating system, the requirements are there. So it's almost like I'm buying something new, but I've already put in some requirements. Yeah.
Sure. So yeah, I think for me, yeah, you probably hit the head on the nail, especially for us that have to manage legacy networks. I have the same fear. Obsolescence keeps me up at night more than an attack on non-routable elements in a legacy network. But given the fact that now, you know, we are going into modernization of these control systems, control plant, in fact, as a whole, should then, just latching on Banele's question, should we then not perhaps be as aggressive, for lack of a better word, as our IT counterparts in creating these and showing then that, by the way, if you are then going to now from a substation perspective implement 61850, which is then routable, essentially now that is, you know, it will be routed over an IP, the internet protocol, similar to the internet. Do we not then, you know, awareness and yeah, an aggression of sorts that IT applies, we become that way?
Yes, I think yes, we must somehow find a way to be aggressive. I just don't know how the IT side does it, because it's the same management. I just don't know. They get everything new as soon as they want it. The management understands that they cannot afford to have an IT system down, but sometimes I don't know how they fail to understand that the operational technology together with the physical system is how the money is coming, and it needs to be taken care of. Sometimes even the physical system can get more attention than the operational technology. So I think maybe we need to do that. And in terms of the cost, I couldn't even answer that. Some plants, people know, especially the ones that must be available around the clock. They know when the trip happens, how much revenue is being lost. So you can use some of these existing tools to say, if this plant is down for an hour, you lose 6 million. Then you know if your server that provides the HMI is down for an hour, or you don't even know it's down, the operator will lose visibility, and for safety might just decide to trip the plant. So such things, I think maybe we need to highlight them to management. I just don't know how. I still struggle to understand how the IT guys get it right. Yeah.
Yeah. So maybe yeah, that SAIEE triad. we once in a while just no, but let me not go there. We are OT through and through. All right. So the next question is from Kaviri Campbell. Kaviri says, kindly elaborate on endpoint security in the ICS environment.
Okay. So there are many different types of workstations. So I see why it could cause confusions or problems, because technically a controller can be seen as a endpoint. But what I mean by endpoint security, I'm mainly talking about the workstations that you find at engineering workstations. There's nothing critical that workstation is doing, so you can go full blown. Put an anti-malware there if you must. Any host intrusion detection, even host prevention, you can put there. But on the operator workstation, for example, you cannot afford to put something there, because if it's going to disrupt inputs of commands, it's going to be a problem. So I'm mainly talking about the workstations, although sometimes I have seen some on servers, but I don't think it's a full-blown anti-malware product that is put there. For controllers, I'm not sure how the research is heading, but I think whitelisting is what the people could be looking at. But for me, I think to protect those, we need to look at the switches, and policies can be effected on switches. You can check the behavior of a controller, for instance, even normal workstations. But endpoint, I'm mainly talking about workstations that are not really used for real-time control of a particular plant. And also at level 3, you must know that there's nothing critical there. So you can go full-blown. All workstations there can be protected. Even the exact equivalent of what is done on IT, you can do it on level 3 because there's nothing. It's just a transit point there.
All right. Thank you. I mean, thanks, Kaviri, for your question. Welcome to Tukani. Tukani Biela from Sigre. Yeah, so Tukani's comment is, I think this pertains to the application, computing, engineering workstations running on legacy systems. The best way to protect legacy workstations is by including a blanket or fabric that protects the network from being penetrated or compromised.
Yes. And that blanket is as much as I don't like obsolescence, is virtualization. It really makes them long lasting, because below you can really protect this old legacy system or workstation under the hypervisor, which could be the latest, and it can have all kinds of security. So you apply some layers around it. So I have seen that virtualization has the potential to do that, and especially where you find that hardware is now lost. If you can find a way to decouple that system, you run it on another hardware platform virtualized, then that's how you continue with legacy systems in a sort of like secure way.
All right. Yes, I think Tutukanu also comes from an area that used to deploy legacy systems, especially in the telecoms side of things. All right. Then the next question is from Andre Froneman. Great session. Thank you, Khomoto. As I said, you're getting 2 Khomotos for the price of 1 today. So, what guardrails do we have that guide municipalities and energy generators? Is the Critical Infrastructure Act already in effect? And how does it relate to generation, distribution, transmission, OT security as of now?
Okay, it is. My understanding is it was done in 2019 and came into effect on 2022. I have not looked into the details of it, but I would like to. I think that because it supersedes the National Key Point Act, it must retain some of the contents of that previous act. So I'm not sure exactly how it. To be honest, I have not really went deep into it.
All right. On that, I think another key question, maybe as a follow up from me with what with Andre is asking, from a regulations perspective in the telecom space, there is also a regulation that speaks to the sharing of communications infrastructure. I know Ronnie brought up the issue of physical security. but maybe also then looking at that Critical Infrastructure Act, look at the potential impact of the infrastructure sharing bill that is brought about by ICASA, given the fact that interconnected networks, and yes, they you know, they may be air-gapped, but physical security, side sharing, and so on, that could have an impact. Just maybe to when you do look into that act.
Yeah, and from your network, you're probably talking these big networks on the data centers. We can see the impact as well with this cloud deployment models, where certain responsibilities of almost physically looks like the same thing, the same server, but half of it now is taken care of by a third party, and the rest is the user. And failure can occur anywhere there, and the troubleshooting also can be a problem. You can have people pointing fingers, but yeah, I think that one, yes, I'll check on the act itself, but I know sometimes for ISPs to protect themselves, they normally do service level agreements and all that.
All right, thank you. All right, Tsuledi, are you still there? But we are.
Yes,
we should be having a conversation that includes you. So maybe then, take the next couple of questions, and if I have follow-ups, I will also do that.
Okay. Maybe, okay.
No,
I'll
do so. You can continue, Khomoto.
No, I was just when Khomoto is mentioning you there, I was just saying it's not just about the IoT protocols that are happening. There's a big change that's happening on the process plants, such as your oil and gas power plants. Although they are not using IoT devices, there's this big standard that's coming that's going to now put in an Ethernet-based field bus there. So you're going to get the standard that was released also somewhere around 2018. It's that of, they call it Ethernet Advanced Physical Layer, where it plans now to introduce a 10 megabits what is that communication network to the field, where now your instruments and sensors will now be able to communicate via Ethernet, and the I/O that you normally see at the equipment room will now be embedded per instrument and I believe actuator. So you can now have field buses in those plants, and perhaps things such as measuring wear and tear you can start having sensors that can start bringing more data upstream.
Well, that's actually an interesting standard, and as this is ever evolving, I think then it will also introduce newer ways of, I guess, having OT systems run. And then in that case, I have a question here from MT. So the question goes, does the CIPA dictate what cybersecurity requirements an organization with critical infrastructure must implement? If not, how does an OT system owner justify where to start and to what degree they must implement the OT cybersecurity?
Okay, this one I can maybe answer it generally. The OT owner, if the plant is brand new, yes, maybe that's where the problems can be. But if you look at, say, for example, a power station, whoever owns that power station was there, say, before 2015. So automatically, it's still going to be classified as a or can I say, if it was classified as a national key point, automatically it will be a critical infrastructure. The newer ones, that's where the challenge will be. But if I can just recall, because this has been handed over to the minister and the National Commissioner of Police, or the owner themselves must apply to that particular minister. So I don't want to just make it up there, to be honest. I don't know the details of the SAIEE Act, but newer plants, yes, maybe we might have issues there, but you just need to know whether is it impacting national security, public safety, I mean food, if you remember, I don't know whether it's Tiger Brands. I don't know, but I can think that has to be critical, because you can kill people if you're going to sell them food or food that can release such viruses. So this one, yeah, I'm not that good at it.
No, very well understood. But regarding the SAIEE, if one were to get more information, like where would you be able to get such information?
I downloaded the act online.
Okay.
Forgot now what website it was, but I just googled it as it is, and then I could find the government website where I managed to get it.
Oh, okay, no, thank you. So it's openly found online. Okay, well understood.
It's openly found, yes.
Okay. So we have another question. This one is from Banele Soni, and it says, in IT, they normally have SOCT actively monitoring the network 24/7 and ready to respond to security incidents. Would this be justified in an OT environment where no devices are internet facing? Sorry, excuse me. Considering that no one is looking at the monitoring tools after hours.
Yes, the problem with the OT or the industrial side is because you have a control, you have already monitoring happening for the process itself, be it the SCADA or the DCS. So it's meant 24/7, and they monitor the process and not security. However, you can configure additional signals for, say, maybe a switch. If a certain switch fails, it will impact their HMI. So the critical alarms do go to them. And then sometimes they have alarm response procedures to say, when this happens, you can call this particular person for maintenance or engineering. That is the normal way. Now, if we want to have for a particular department to say, no, this is security now, we just want purely network based. Sometimes I don't know whether it becomes a problem for the organization to say, we already have this.
Yes.
Some can leverage the existing system, and then the one thing I can think of is that maybe perhaps through the use of a historian, you can create your own custom sort of like a SIM solution, and then you don't have to have people manning it 24/7, but they can be on standby. Use the existing operators to say, when you see this, call this other one, or make it just dedicated to say certain people will monitor the security aspects, set alarms. Or sometimes you can do that with the historian or the SCADA or the DCS, depending on the level of it. If it's the newer ones, they will include security with them, because it's still this same networking devices. But if I can recall, sometimes if you look at the switch, only key signals are brought to the system. The rest are still at the switch. You need to now go physically at the switch and check the logs, which is a problem. We cannot go device by device. It needs to be single and correlated. So it can work. It's just a problem that there's other control systems that are there already. but yeah, it should be allowed. Like I said, for me, I don't think these things are expensive, especially if you have the big field equipment out there.
Can I have a follow-up?
Yes.
I think the first slide with the Purdue model, well, second slide, where you showed then the possibility of attacks. From there was the cloud that is a utility WAN. So from
Yes.
I guess with the follow-up question, maybe that's speaking to how load shedding is affecting all of this. The utility WAN is also managed 24/7. Now,
Oh, yes.
this notion of a SOC, in instances, probably in literature and in other applications, I would presume that it's from applications that do not have a utility WAN and are then buying services outside from a third-party telecommunications provider, for example. So for maybe your opinion, again, this is the SAIEE, you're allowed to also give your opinion. It doesn't have to be official with your day job. In a scenario like that, where there is a utility WAN that is also owned, that is part of the, say, the integrated power system and OT systems, is there a need for a SOC? Can you not just take the same element that because a utility WAN has routers and switches, and that also can be hacked or are vulnerable to threats? Why duplicate networks?
Yes, my personal opinion is there's no need, because the utility WAN is big. It has already a network management system in place. It can either use that one or draw some of the whatever signals that is required. In fact, it's probably even better suited to even be a SOC on its own, because you are monitoring routers. You might as well have it's networking protocols and security protocols, and the networking ones. I don't see how anyone can tell the difference. I think for utility WAN, there's no need. It's just to see maybe application, how far can it go? Can it also assist with the substation or the power plants? But you carry the data, so there is a possibility to even help route that data, for example, for the primary equipment to where it should be. But for the utility WAN, to be honest, for me, there's no need. It is a duplication.
Right, back to you. Thank you, Tsudesh. Back to you.
Oh, thank you. In that case, this is going to be our last question for the session. It's from Andre Frontman, who says, what is your suggestion on modernizing OT jumper servers? We see OEMs being hacked, putting South African organizations at risk. Valid credentials completely bypass all security controls. Any suggestions in this space? In this one, I guess you did touch a bit on it, Omoto, when you mentioned how these new field devices are coming with.
No, it's a yes. No, it's a correct one from Andre there, because now this one is worse, because you are coming from the outside. Sometimes these guidelines, you just say them and they look like they are cliches, but meanwhile there are consequences if things like that are not done. OEMs sometimes can log in remotely, even though there is this idea of saying it's secure. They come via the IT and then come to the industrial DMZ, where the guys who control the control system put their servers there. Those servers sometimes, yes, it's true, the passwords are still reusable. You can't tell where somebody is connecting from, even though it's a jump server and physically they are now on your plant. They can bring them down that plant because there's no there's no monitoring as well. It's almost to say at commissioning, that's how it was. And then 10 years passed, nobody does anything there. So the suggestion there, coming outside this one, there's no any other way. They need to implement multi-factor authentication, and they need to monitor those connections. If it means they automate it, they must, but they have to monitor that. Yeah, that's how I see it. And it's just that they're coming from outside, they can be from another country. It's equally true to say within the plant, people still know how to, it's just that they are scared, or maybe they don't know how to use the application. They do what they are used to, but if they wanted, they can go into the application server and then log in. There's no control. So for me, there is definitely directory services, but even these directory services, there's this big problem of passwords, system passwords, default domain passwords. Somehow there's always, I don't know whether by design, a system was designed for one person to log in. So this is the biggest problem, but at least you try to limit it to say controllers, workstation, the password must be in a database somewhere. And then in a certain room where at least you can say, we know 4 or 5 people come in there. But this is an ongoing problem of passwords. And apparently the answer lies in decentralized systems such as blockchain. So it's ongoing. This one, as far as I know, I haven't seen a solution that can really get rid of this problem. But multi-factor for coming outside, it's good. Ideally, it must come via your company IT. Let them at least be a blockage. But once they're on your DMZ, it's your baby now.
No.
Cool.
Okay.
All right.
Okay. Cool.
Yeah.
Well,
Looking at the time as well. Absolutely.
yes. Well, thank you to the viewers for joining us today, and it was really informative and wonderful session. And I hope this extends to all our attendees. And please, under the chat boxes, you can go and check for. We can check for the websites to basically register for the SAIEE Awards, which is one of our next upcoming events. Well, in that case, ladies and gentlemen, have a wonderful evening. Thank you very much.
Thank you.